The common and very relevant kind of motion in nature is that followed by waves. A wave is an oscillatory motion that propagates energy through space. At each point of the wave, there is an oscillatory motion at a small scale, but there is a global large-scale motion that transmits energy. We can think of it as a perturbation that travels in space, that creates local oscillations of the medium. There are different types of waves. Mechanical waves propagate through a medium such as air, water, land. Sound, ocean waves, earthquakes as just a few examples of mechanical waves. There are also the electromagnetic waves. These don't need the medium to propagate. They can travel through the vacuum of outer space. They are oscillations of the electric and magnetic fields. We also have the gravitational waves. They also travel in space through vacuum. They make oscillate space itself. In the case of mechanical waves, these make oscillate the medium, for example, the air if it is sound in a classroom. Sound is a pressure wave. It means that there are changes in pressure that propagate. Sound makes the molecules of air vibrate, and this vibration is transmitted from molecule to molecule. It goes from the loudspeaker of your computer to your ears. Your brain interprets the oscillations and sound that might have meaning if it is sentences you are hearing. The energy and also momentum is propagated with the waves, but the air molecules do not move, they only vibrate. They follow a harmonic motion around their equilibrium position. All waves have an amplitude, which is related to the energy. They all have a frequency, a period, and a wavelength. The amplitude A is the maximum displacement of the oscillatory motion of the molecules of air. The frequency F is the rate at which they are oscillating. The angular frequency is 2 pi f. The period T is the time they complete one oscillation. The wavelength lambda is the distance between 2 points in space that have the same phase. For example, both of them are at the maximum position, or both of them are at the minimum, and so on. Be careful, because some people think that the amplitude is the distance from maximum to minimum, but it is not. It is the distance from the equilibrium position to the maximum position. The wave propagates at speeds that depend on several aspects, depending on the kind of wave. The frequency and the wavelength are related through the speed of the wave. Velocity is equal to lambda f. Wavelength times frequency. Waves can be classified into longitudinal and transversal depending on the direction of the vibration in comparison to the direction of propagation of the wave. If the oscillations are in the same direction as the propagation of the wave, then we have longitudinal waves. If the oscillations are perpendicular to the direction of propagation of the wave, then we have transverse waves. Light is an electromagnetic wave, and it is a transverse wave. The electric field oscillates perpendicular to the direction of propagation of light. Gravitational waves are transverse waves also. The oscillation in space are perpendicular to the propagation of the wave. Earthquakes are complex and produce longitudinal and transverse waves. If you like surfing, you are enjoying transverse waves. The water goes up and down, but the surfer uses the wave to move forward. Although right at the end, when the wave breaks, then water actually moves forward. But all the way until that point, water just moved up and down. May science be with you.